Hello everyone, in this video I'm going to cover SQL aggregate functions, the group by clause, the having clause, and distinct. So on the screen here I'm in MySQL Workbench. I'm going to go to my local server, and for demonstration purposes I'm going to use a little database called Record Store, and since I want to work with that one I'm going to double click on that so that becomes the active database. And if I'm not familiar with the database, there's a couple things I can do to take a look at what's available, the tables and attributes and relationships. So I can open tables. I see the list of tables here, but one of the most useful features is to do a reverse engineer to get an EER diagram. And I do that by, in the menu, clicking Database and then Reverse Engineer. I get dialog here. I'll just walk through. I'm going to just take all of the defaults, just click continue a couple of times. I want to see the EER for the record store in this case. I'm going to continue and execute. When that finishes, I get a diagram of my tables and relationships. And in this case, I want to take a look at some key tables. This is kind of a classic customer orders and order items database example. So I'm just going to rearrange some of this. There's a couple things here I don't really need, just for our purposes. So I'm going to look at, this looks a little messy to start with, but you'll see what I mean in a second here. There we go. So in this case, I'm interested in customers and their orders and order items. Order items also is attached to the products list. Orders is attached to a little lookup table called lookup order status. And the relationships that exist in an EER, at least here in Workbench, if I highlight or just hover over any of these relationship lines, of course, the fields that highlight, in this case, customer ID, both in the customers table and orders table, both highlight, and that shows me what that relationship is. I can also see the ends of the line right here and right here. This is a one-to-many. The link on the customers table is 1, and this looks like a little crow's foot. That means many. So in the case of the customers to orders relationship, for any one customer, there could be 0, 1, or many orders. So I'm going to keep this open and use it as reference as we progress here with the examples. I'm going to go back over to my local instance, and I'm in a query window here. So the first thing that we're going to take a look at is aggregate functions. And MySQL has a very large number of these aggregate functions, which can be used for many different purposes, like counting and summation, taking an average and mean and maximum, minimum, and many others. So we'll take a look at a few just for examples. And the important thing to realize is that when we select data, say like this, select all from customers. When we run that, we see that we have all of the customer data, all of the rows and the attributes, the columns. In the bottom of my output, my action output, I see 500 rows, which indicates that there's 500 customer records in this table. If this is the format of how I want to see the data, I can certainly use a query like that. But what if I just want to know the number of records in this table? I don't want to know, I don't want to see all of the data. I don't need that. So we can use an aggregate function here, like this. Notice that this query is very similar to the first one. The difference is instead of using the asterisk to say all, I'm using an aggregate function. In this case, it's called count. Count is one of the common aggregate functions. If you're familiar with Microsoft Excel, a lot of these functions will look like ones that you may have seen there if you've used functions in that software. So if I run this query, notice that I get a number there, and I don't have all of the rows and columns. I just have this aggregate value. Aggregate meaning just the result of a calculation or a function. In this case, it's the count of the number of records in this table. Now I can do the same thing with a where clause. Okay. Just like all other select statements, I can have a where clause, whether that's one condition or multiple. So if I run it this time, I get, you notice number 12. That means there are 12 customers in the state of California, right? If I do this without the aggregate, I should see the 12 records. Okay. So these aggregate functions, you can find a full list of those in the case of MySQL on the Oracle support website. Let's take a look at a different table. Let's say products. All from products. Okay. And if I run that, I get the full product list. There's a few hundred rows in here. And there's a couple of things I want to point out. When we take a look at the products table, if you notice the data types of the attributes here, the artist, the title, and the media are all varchars. It's actually character strings. But we have a couple of numeric data type attributes here. For example, released, so that's the year, and the stock, which is an integer as well, and that's the count of how many of each of those items we have in stock on this last column. So when we're trying to use these numeric values for calculations, sometimes they, using aggregate functions, for example, sometimes it makes sense, and sometimes it doesn't make sense. For example, the released year, it's stored as an integer, but you wouldn't have a sum of all of the years in that attribute. That really wouldn't give us any valuable information. But let's say I wanted to know what is the total number of items I have in stock, regardless of what the item is. I just want to sum a total of the stock column. And so I can use another aggregate function called sum, and from products, oops, made a mistake there. It's not an asterisk, it's the stock. And so in this case I have my aggregate function sum, and I'm specifying inside the parentheses which attribute or column I want a sum value returned. And so this is going to give me a single value, just like the count did, and it's going to give me a total of the stock value for every product that we have in this table. Okay, so let me run that, and so I have 4,820 items in my products table. That's using that sum aggregate function to add up all of the values in that stock column. There are several other numeric functions I could use. For example, let's try average. Average is AVG in MySQL, and I'm still going to use that same attribute name, stock. I want the average. So what will that tell us? That will tell us out of all of the values that we have in the, 300 rows, what is the average of that column? And I get that. I get 16.28. Notice that the data type in this case is not an integer, right? It's a decimal value, and that's due to the fact of the way in which we calculate average. So if I was going to store that somewhere, I would want to take that into account. So that demonstrates just a few aggregate functions. All of the database engines have aggregate functions. We're looking at MySQL in this case, but Microsoft SQL Server, Oracle's Enterprise Database, SQLite, and others also have aggregate functions. Some of them are the same as the ones you see here. Count, sum, and average are quite common, but then there are others as well that are proprietary to different database engines. So the next thing we're going to do, get rid of that, is take a look at the group by clause. So we've learned, the select statement is the statement in SQL that we begin a query. And most of what you add to a select statement, the where clause and the order by, etc., they're called clauses and they're optional. The group by clause is also optional, and we use it to group data together. Let me show you what I mean by that. We'll go back to that products. We'll go back to the products table, and I'll just run this so we can see everything. And let's say that I wanted to know, I'm going to use an aggregate function, and I want to know the count of products in our products table, and I want to know how many items I have per year. And when we looked at the aggregate functions, we can use the count. And if I were to just say select count from products where released equals a specific year, I would get the count for just that 1 year, right? So let's try that. Count from products where released equals, I'll just pick one, 1975, sure. Okay. And if I run that, I get a number. It says 19. Okay, that makes sense. But what if I want to know how many were released for every year? And so the challenge that I have is that the order by clause is how we sort our result set. And my result set here is just a single row, so that doesn't really help. So how do I go about getting this aggregate result set to then show me a count for every year? So instead of a where clause, I'm going to add group by. Okay. So group by in this case is going to say, okay, the result of this query is going to be a count, and it's going to be based on that released column. So what I want to do first of all is put released in place of the asterisks. And the reason that I'm doing that is because I'm focused on the released column. I'm not interested in all of the other attributes that we have. And one thing we did not see before when we looked at the aggregate functions is how to include an attribute along with the result of our aggregate. And so I've added the released column here, and that's going to show the year, and this aggregate function is going to show me a count for the released year. And in fact, I can also use there's an operator called as. Let's just say something like this. This is going to give me a title for the resulting column. Okay, that's mostly just for our purposes to, for readability. It doesn't really change anything with regards to the calculation or anything. So the one problem that I have though is that I'm not using a where clause. I took that out. So what I need to know is how do I get each year and each year's count together. And I do that by using group by with the released column as what I'm specifying that I want to group this by. So that means that for each year, I will have the year, how many items I have in my products table with that year. And because I'm using group by, I'll get every year and its sum. And I can add the order by statement as well to sort them by year. So let's just run that and take a look at the result. So notice that I have my released year, and it's sorted numerically by year. And now I have this, this is called an aggregate column, meaning that total in stock is not actually a field name, right, in the table. This is the result of using the count released as total in stock. Okay? And I'm getting this grouping because of the group by statement. So for example, 1969, I have 3 items in our products table that were released in 1969. 1970 has 40, 71 is 27, etc. The other clause that we wanted to take a look at is called having. So one of the things about select statements is that what we see here on the screen in our result grid is called the result set. So this data is not stored in the table. This is the result of our query. And so this is called my result set. And everything that we include in our select statement, including the where clause and this group by and the order by, acts on our query in the process of it building the result set. So because I'm querying the products table, as we have seen before in previous content, the select statement lists what I want my result set to include. In this case, I'm including the released attribute, the column, and I'm using an aggregate to create another column, with that released count from the products table. The group by is going to group it like we see in that result set, and we're sorting it using the order by. So all of that happens in the process of building the result set. But what if I wanted to know, this result set, but I want to filter out some of the results? Okay, you notice that we have, for example, that very top row has a 0 in it. Maybe I have a couple of years that only have 1 or 2 items. What if I wanted to know just those with a certain number or more? So what I can insert here is basically the same aggregate that I'm using in my select statement. I repeat that here. Got the parenthesis there. And what my condition is. Let's say, I don't know, I want to know all of those that the result set informs me that I have more than 20 items. So what does that mean? If I look at the results that we currently have, this is without the having in it. The first 2 rows, I have a 0 and a 3, and then 40. There's a 19, there's an 18, and a 2 and a 1. Okay, let's say I want to know only those in this result set that has 20 or more than 20 items. Okay, so let's run that, and we'll take a look at the result. Notice that my result set is smaller. There are no values here 20 or less, and I'm still sorting by the year. Right? And the having, the most important thing to remember about that clause is that it does not affect anything in the select statement until after the result set is built, meaning my select statement has completed, I've grouped, or I've used a where clause or whatever. Once the result set is done, then the having clause is applied. This condition, this is called a filter condition, is applied to the result set, not actually part of the initial select statement, the query. And so I can use anything inside these parentheses that will help filter my result set down even further than what my original select statement provides for me. If I change this again, let's say we'll change that to 40 maybe, and run it again, I now have a smaller result set. So the aggregate functions and the group by and the having clauses are used together a great deal to summarize and analyze data, to add filtering, to group data together based on some condition. We have, for example, I'm using the aggregate function here, count, combined with the group by, and in this case also combined with having, to get a very small result set, and it's also summarized, right? That's what the aggregate functions provide for us. The last feature that we want to take a look at is called distinct. And this is a clause we can add to a select statement to eliminate duplicate rows. So let's take a look at, let's try this. State from customers where country equals Canada, order by state. So this query is going to give us a list of the states, the state abbreviations in the country of Canada, and it's going to sort those by that state attribute. So let's take a look at the result of that. Notice that we have duplicates, right? There's several in AB and BC, etc., right? Well, what if I wanted a list of the states that are in Canada that we have in our customers table, but I don't want those duplicates. I just want to see the, it's called distinct list. Notice that we insert this right at the beginning of our query, right after the select statement. So now if I run this, now I have a distinct list of the states in this case. Distinct is very useful when we want our result sets to have unique rows. Distinct will be applied to all of the attributes that are included. In this case, I only included state, but if I had additional attributes listed, it would apply to all of them together. So a unique row would be any row where the values in whatever attributes that I've provided are unique. In this video, I've covered aggregate functions, the group by clause, the having clause, and distinct. Best advice is to practice with these in various ways with your tables, and let me know if you have any questions. And thanks for listening.